Whose life would be better if you knew more C++? Whose life would be better if your coworkers knew more C++? Let's get started.
All right, so hello everyone. My name is Inbal Levi, and today I'm going to talk about smart pointers and RAII. So let's start with who am I? I work at SolarEdge. I'm an embedded developer. I'm also an ISO CPP director, SG9, which is the Rangers group chair, LEWG co-chair, this is the Library Revolution, and Israel NB chair. I participate in ISO meetings. I teach C++. I sometimes publish papers and articles. I think it's safe to say that I'm into C++. Now, I haven't put a photo of myself there. I don't really understand the point of putting a photo because I'm right here. So hello. Maybe someday I will, but okay. So in this talk, we're going to talk about the ownership model of C++. We're going to look at the syntax and design of smart pointers, how to successfully use smart pointers in our code, and what the future holds for ownership in C++. No, I'm not pretending to know all the future. So what does ownership mean? Ownership usually refers to the management of object memory and lifetime, and there's multiple ownership levels. For example, we have value level. So if I have an int, that would mean the value of the int. Then we have indirection, int pointer, and there's wrappers as well. So for example, iterators are example of wrappers. And I think we should consider ownership with extended definition. So usually when people say ownership in C++, they mean the memory. But I also think we should consider the value. So for example, if I have an int that represents month, I can update the data. I can also invalidate or remove the data. But if my int represents a month, that means that only 1 till 12 are reasonable values. And I can invalidate if I put 13, for example, even though I still have the memory, etc. So I think it's important to make this distinguish between the value and the memory when you think of ownership. Each ability has different effect on our program and our logic of the program. So in C++, we allocate memory on heap. And we don't have an inherent mechanism for clean exit. And we can use smart pointers to achieve that. They're provided in memory header, and they help us bridge the gap between manually managed memory and automatically managed memory. So I want to go over something very briefly that most of you probably already know, but I think it really emphasizes that point. So let's first start with two terms. Compile time is what we know about the program when it's constructed. And runtime, what we know about the program when it runs, okay? It doesn't have to be on the same machine. Actually, usually it's not. So I have an IDE, I write the program, I get a library, I give that to the compiler, and I get an executable that already holds the stack allocation. But then I take this executable and put it on my target machine. And when I run it, I occasionally need additional memory from my environment. That could be the operation system, it could be operating system, it could be other things in case I don't have one. On interrupted languages, which are managed, I got my IDE in my code, and sometimes I import my library. Then I move it to my target machine. But in order to run my program, I also need some kind of a manager. So the manager is responsible for, this is what happens in Python, for example, for allocating private heap. And then when the program needs some kind of additional memory, it goes and requests the manager for that. And once the program is done, the manager is the one that is responsible for giving the memory back to the operating system. So basically, to my eyes, smart pointers helps us go from the first, from combined language kind of behavior to more closer to interrupted languages kind of behavior. So we're going to talk about unique pointer, shared pointer, and weak pointer. Unique pointer represents single ownership. Shared pointer represents a mutable ownership, and weak pointer represents known ownership. So let's start. Let's look at a simple program. So we have an int allocated on the heap here, and we have some condition. If we met the condition, we return. And here we have, of course, memory leak. If we replace that with our unique pointer, for example, we can know for sure that once we have, first of all, the allocation, and then we also have the guard. So once we reach this return, we know that our memory is being freed and the program is safe. So smart pointers basically create an ownership model for our allocated memory. We can also do those two things at once by using make unique, which is a factory function from the standard library. And make unique, just like new, can also throw exceptions. So if you want, we can wrap that with a try-catch block. Should be, probably. So I wanna show you an example of why make unique and make shared, the equivalent for shared pointer, are really useful. So let's look at the first function. We have a function here, takes a unique pointer and allocate new int 4, and additional here, and additional unique pointer allocates new int 2. But if the second one throws, then we still, we don't have necessarily the protection because we still haven't got the wrapping, the guard, because we don't have that obligation. On the other hand, so here basically we will get a memory leak, or might get a memory leak. On the other hand, if we have make unique factory functions, then the first one is allocation plus guard, and now even if that one throws, you're safe. So that's additional reason why you should use the factory method. You'll see additional ones in continuation of the talk. So as I mentioned, unique PTR represent a single owner. In order to pass ownership, the resource will have to be moved. We can also, I just wanted to demonstrate here, we can also use auto, and you see later why auto is better, specifically in those contexts of ownership. And here we have unique PTR that wraps a string, allocates the value of the string is John. And of course, we will get an error if we try to take the resource of name1. So what we need to do is to move the resource out of name1. And that leaves name1 in invalidated state. Now, I haven't written here, for example, empty string or null pointer, because this is an implementation detail. And accessing that is undefined behavior. So you should really make sure that you don't try to access things that you have given their ownership or gave up on their ownership. And unique PTR can be used with facilities which requires copy. We'll see a bit later also with details why. So there's an additional thing I want to tell you about smart pointers. So important thing to remember about smart pointers is that the wrapper is not the object. I also have initials here that are twin to. I think it really relates to the topic, because smart PTRs are like twins to pointers, but they're not exactly it. The reason I'm saying that is that sometimes there's guidelines of using smart pointers just like pointers, and that's okay. But you always have to keep in mind that this is additional object, and you're also going to see later it have overhead in memory and in runtime occasionally, not to unique PTR, to shared PTR. So I just want to show you two quick APIs for unique PTR. You can find the rest in CPP reference if you like. The first one is release. Release is returning the pointer and terminate the ownership. So we still have the lifetime of the object remains, but the ownership is the one that goes away. With reset, we do the opposite. We terminate the object and we replace the ownership. So the guard actually lives, but whatever it guards on doesn't stay. Okay. So as I mentioned, unique PTR is very useful and can be used in combination with standard library facilities and with arrays. So it have overload that actually calls delete parentheses, just like we do need with arrays. So I just want to briefly go over different uses of unique PTR. Now, I just want to emphasize that I'm not recommending to use those forms always, just when you need them. So, for example, you can have a vector of unique PTR of int. It doesn't mean that you always have to use that. Sometimes you might want to have that. And in that case, you can also have, add make unique of int, and you have a protected object. If you want to initialize multiple objects in this way, you're going to have to use initialize a list syntax. And you can do that by creating an array of unique pointers and then use move iterators from the standard library, make move iterators. That's helper functions. And in this way, you can also have the initialization not in one line, but in two. You can also have unique PTR of C-style arrays. So as I mentioned, that will call delete as needed. And starting from C++ 20, we also have make unique for override. So what's the difference between make unique and make unique for override? So for user-defined type with default constructor, it doesn't really matter. But when you have, for example, array of primitives, that can actually affect your performance. So make unique for override doesn't actually call, it only calls default initialization. It doesn't call, for example, value initialization, etc. So for people that are working on high performance computing, that actually matters, can matter. And we can also have unique PTR of a container. So if I want to define in my program that my container cannot be copied, I can do that by wrapping it with unique pointer, and of course, I'll get the proper error. But what about performance? We talked about performance before. Let's look at how do we deal with that. So in this slide, we're going to look at the structure of unique PTR of the standard library. Don't be afraid. That's a simplified code, but still from GCC's libstd C++. So first of all, the structure of the file. So we have a unique PTR. Unique PTR is defined in header. So that already tells you that this is a compile time utility. It have part of the unique PTR header is for single objects. And you also have implementation for array of object of runtime length. So let's go deeper into the single object, just because it's simpler. So of course we have a class, and we have a member. The member takes the type pointer and deleter. And I'm going to talk later a bit more about what is this deleter. But if we don't provide it, you'll just get the default deleter. This member inherits from unique PTR implementation. And as usually things in libraries do, you occasionally hide the implementation. Here we have our constructor. The constructor initializes the member. And of course, we get the pointer. We hold the pointer in our data. That's what we do. We try to guard the pointer. And deleted copy constructor and assignment operator, of course. And the defaulted move constructor and move assignment. And deleter and additional implementations for make unique for override that we saw before. So this is the whole thing. If you go into the standard library code, you'll see those. You can actually search for them. I didn't change. I just removed, but I didn't change the definitions, etc. So feel free to go deeper into that. I think it's very interesting. OK, going back to ownership, let's define the following characteristics. So I have something, when I look at ownership, I'm thinking of it in terms of events. And I want to share with you that way of seeing ownership. So I think that ownership events can be, for example, moving an object, passing an object as a function param, and returning an object from a function. In each of those things, we are creating this point of decision in our program, okay? So we have to address that. So let's start with passing an object as a function param. For example, I have here a very simplified library, devices library. It has print, it takes a unique PTR and a regular device PTR. And let's say in this example that I don't want this as overload, I intentionally want to have different print functions. It's just for the sake of demonstration. And I create a pointer and I call print. Of course, I'll get an error because I'm trying to copy, I'm taking the unique PTR by value. It means I'm trying to copy something, and we just saw in the previous slide that it's deleted. So I have two ways to deal with that. And I need to choose between those in a way that represents the ownership that I think my program needs to have. The first way is for the user to give, so the user code to give ownership to the library. In that case, instead of calling print, I'll call print with move. I'm giving away my resource. That would work. Another way to do that is keep the ownership in the user code. So in this example, instead of taking by value, I take it by reference. What I'm trying to do is basically say, this resource stays at my code, the user code, for example, and I want to pass it, but only by reference, so I don't give away my ownership. Now let's look at returning an object from a function. Here I have a different example of getDevice function. Now I fixed it, I take it by reference, and I return the value in dev. So what do you think will happen here? You can, okay, everyone who thinks that this will work, please raise your hand now. Okay. Everyone thinks that this will fail, raise your hand. Everyone who haven't raised your hand, I guess you're not sure. That makes sense. So that, yeah, that will actually fail. We fix the value that gets into the function, but we also try to copy it on the return. How about this one? Here I have a function that actually creates new device. It creates make unique pointer of the device. It initializes it, and then I try to return it. Will this work? Let's start with raising hands. Who thinks that this will work? Okay, that's good. Who thinks that this will fail? Okay, and the rest are unsure. It makes sense. Okay, so I cheated a bit here because this shouldn't have worked. But we have here something that's called copy elision optimization. Starting from CppCon 17, this is mandatory in cases that are defined in the standard that I wouldn't repeat here. But basically what we get is that instead of having this object copied in the return, just like we normally used to having, this might be optimized out. Now, this could be either not created or just the parameters. Basically, we moved it 1, 2, 3, 4, which is our serial number for the device. This could also just be moved into the object that waits in the main. So there's different ways to go to do copy elision optimization. This is implementation, but still we get that. And this is named for our return value optimization. How about the third one? Now that you know a bit more about that, so who thinks this will work? Great. I think, yeah, that's good. Who thinks that this will fail? All right. Okay, so yeah, this time, of course, it will work as well, but this is not a named value. This is an unnamed value, return value optimization of a temporary. So yeah, so I think it's interesting because this example shows us that sometimes optimizations are breaking our image of the program and of the ownership. So we expect something to happen, and it makes sense, but then it's not necessarily what the code delivers. So I think something to take from that is that you still need to think about ownership in your program, even if it works, even if it looks great. Still take under considerations. Do we really intend to do so? For the first example, for getDevice, there's again two ways to fix. The first is the library gives ownership to the user code back, so we move it outside. The second is that ownership remains in user code, so here I did this fix when I returned by reference, and for example, take by reference, return by reference. So this thing is not mine. I use it, but it's not mine. And then, and the main, of course, I need to fix it. Okay, so I want to emphasize that I don't recommend you to write libraries like that. This is an example that tries to focus on the return and values and the passing values to a function. A bit in a few slides, we're going to see a few ways that I recommend to actually write your libraries when you try to interact with smart pointers. So this is a simplified example. Any questions so far? I can pause a bit. Okay, great. So let's move to shared pointer. Shared pointer, as I mentioned, creates multiple owner model. It have overhead both in memory and in runtime. And again, I repeat my sentence, the wrapper is not the object. Okay, so if you care about those things, take this under consideration. And the design perspective, you do need sometimes to consider smart pointers as pointers. So let's look at how shared pointer works. Basically, we do shared pointer by managing reference count. So we have dev1 device. We create a shared point for that device, and we initialize it. And then we get heap allocation for the manager, and of course, our object. And the manager, which is the part of the shared pointer that is responsible for managing this ownership, have a pointer to our object. Now we get into this scope, and we create device 2. Of course, we have additional pointer, reference count go to 2. And we reach the end of the scope, the pointer disappears, reference count go to 1. And of course, when we copy again, we increase reference count. And once we end the function, both of the pointers disappear, reference count go to 0, and our allocation goes away. So additional reason, as I mentioned, I'm going to show you additional reason to use make shared and factory methods. Make share, make unique allows optimization by allocating the manager and the object at once. So actually, I should have added make unique here. Sorry, that's a mistake. But make share does. We already saw that make unique doesn't need the additional. So as I mentioned, the wrapper is not the object. I want to show you a common pitfall. So let's say I have a device, and I want to have these simplified functions. Again, don't think of this simplified example. Think about a library that takes a device pointer, does something with it, want to manage some shared pointers, etc. And let's say I wrapped my creation of shared pointer with a function. So I have my object, I have my wrapper. I call the function wrap with shared, which is supposed to give me back my shared pointer. And when I do it again with the same pointer for the device, of course, I will not get the same manager. So this is something that can be a common pitfall when you start working with shared pointers, and you should avoid that. And again, we're going to see in 2 slides or so how to actually do these multiple shared pointers to the same object correctly. So now I want to move to weak PTR. Weak pointer is non-owner model. We use that to claim this ticket or request for shared pointer without actually claiming ownership. So if you want to have access to something but not keep it, not actually claim ownership on it, we need to use that. It's common use case to use weak pointer is to prevent circular references. I'm actually not going to go deep into that topic in this talk because there's so many examples online, so you can look for them. That's like the first example for how to use weak pointer. But I want to go briefly over the functionality of weak pointer. You can call useCount to return the reference count that you just saw in the previous slide. You can call expired, which verifies the state. And you can call lock, which returns a handle with ownership, which is basically a shared pointer, to your object. So let's look at this code for a second. I get a shared pointer, I create weak pointer from it, and I check whether it is expired. Do you think, okay, so there's some cases where this code is not gonna work as we want, and we're gonna see it a bit later. Okay, so basically smart pointers are thread safe. I have a pointer, and I point to the heap. Let's think of this as shared pointer. I have another pointer. Again, pointers are handles. And I point to the heap. And here I have, for example, a thread, an additional thread, and they all goes to the same place. So as I mentioned, smart pointers are thread safe. But if I look at the example that I just saw, let's say I start with a single thread. I get to the check. I checked, and I get that the pointer is, in fact, not expired, so I can take a shared pointer from it. And then I move to a different thread, and the thread, for some reason, invalidates my shared pointer. Now I go back to, with context switch to where I was before with my thread, but unfortunately, I've gotten something that I didn't expect. Now, there's additional problem here, because in this case, again, this is implementation detail, but in this case, you'll actually get a shared pointer with a device of default initialization. So if, in this example, device gets a serial number string, you might get empty string. That's not what you wanted, but you still use it. So this is not what we want. What we want is to use the lock function that we just saw, because it do multiple things. First of all, it locks. First of all, it checks whether this is expired. Then it locks. Then it returns a handle to the pointer that we wanted. And this is actually the safe way to use weak pointer. So my point is, smart pointers are thread safe, but make sure you use them right. So, okay, so now, as I promised, let's look at how we really want to use shared pointers with library. For example, the interaction of user code with library with shared pointers. So I have a device here. It gets a string, which is the serial number, as we saw before. And I allocate make unique pointer of that device. And now I call this function called add module, and I use it correctly. I passed it by reference, as we saw before. And I wanna add this A thing that's actually to my existing SN that is representing the model. Sorry. Okay. But what's the problem here? So, sorry, I just jumped. Okay. If I replace my shared pointer with my unique pointer with shared pointer, as you saw in the function declaration, now I have the user code is now not fitting to my library. That's a problem. So a way to do it more correctly is to actually create this sort of a factory method called getDevice in this example. And then instead of creating my object by the user, I create it by factory method that the devices lib provided. And that's additional reason why I said that I think auto is very useful, because now if I replace my unique pointer with shared, the user is not aware of it. My API is clean. Okay, so now we got to how do I create multiple shared objects to my device? As we saw before, the creating function is not the right way. So I have getDevice function, and I create this shared pointer to the device. But this is the same function that we saw before. Okay, we have a problem. If I'll call that again, I will get a different object. So what we should do is use library facility called enable shelled from this. We inherited from enable shelled from this with our object type, device in this case. We have a private constructor, and then we define two functions. The first creates device. So I need to give some kind of interface to the user to create devices because I just hidden my constructor. And the second is getting a handle to this device. In this case, shared from this because I want a shared pointer. So the way to use that would be, first of all, I create a device. Dev1 is a new device. It got SN 1111. And then, instead of calling these wrapper functions that we saw in previous slide or something similar, what I do is that I call my getHandle function to get a shared pointer for this device, and this will work. Great. All right, any questions so far? Good, yeah. You mean getHandle, not create device, right? Yeah, that's what it does. Sorry, I will repeat your question. He asked, sorry, what's your name? Adam. Adam asked if he calls this method again, what does it returns the shared pointer to the same object? And the answer is yes, that's the way to do it correctly. No, it's the same, yeah.
We do have one question from online.
Sure.
And the question is, can we use weak pointers as a way to say, this object is only reading the data here and won't mutate it as a design pattern in our code for other maintainers?
Sorry, could you repeat this pointer, this object is?
Right, can we use weak pointers as a way to say that the handle is read only? We're only reading the data and not mutating it.
Right. Okay, so I'm not sure that I would recommend that pattern because weak pointer, even though it's weak, in order to use it, no matter how you want to use it, you have to convert that to shared pointer. Once you're converting that to shared pointer, if you can't control the user behavior with this shared pointer, then you don't get the safeness that you want. So I wouldn't recommend that. There's probably other patterns that are more, yeah, go ahead, Ansel.
You mentioned that the weak pointer lock, you said it returns a default initialized object. Doesn't it return a default initialized shared pointer?
Yeah. So I might have said object, but I meant default initialized shared pointer of the object, yeah. Thank you, sorry. Yeah, so Ansel asked if when you call weak pointer lock, I said that it returns a default object. It actually returns shared pointer of the default object, yeah, sorry. Default initialized shared pointer of the object. Okay. Thank you. All right. Right, so yeah. Okay, so just one more example that I wanted to give you, and this is not necessarily relevant to smart pointers. This is just an API sort of point. I can also, instead of creating this complex interface, of course, always create this sort of a manager, and then use this manager to pass this manager the values that I want in order to create my object, and this manager holds the vector of the objects, etc. So I want to say that sometimes it is important to share pointers with your library And in that case, you have to do it correctly, preferably in a way that you make sure that you keep the ownership as you intended. But it's not always the case. So keep in mind that there's different ways to create this API. OK. So now let's move to RAII, as promised in the title of the talk. RAII is Resource Acquisition Is Initialization. It can be used to manage other resources. So here, I want to show you a very simplified example. And again, don't read this code as a guideline. I have a wrapper. And in this case, I have a function that gives me a serial number for a device. Let's say I have these certain use cases and restrictions, and I have to have my serial number look in a certain way. So I use this function, and it gives me back a serial number. Now I want to have some kind of ownership on my serial number. But this is not a memory ownership. This is more of a logical ownership of this thing. So in this case, in this example, what I did is I created a wrapper that writes the serial number to a database, for example, when it's created, when I capture it. And then when, at the end of scope, it erases the serial number from the database. Now, I try to emphasize here that ownership, RAII, can be used not only for memory-related topics, and ownership is also something that you need to make sure that you well define when you talk with your coworkers and when you try to define the design of your program. So, OK, so this wrapper is nice, but clearly we have a better way to do that. So a better way to do that, I think, would be to use with unique PTR deleter that you saw before. So the deleter, as mentioned, can be user-defined. We can pass the unique pointer functor class, which implements the operator parentheses, and does whatever we want to do when this ownership ends. So again, it's not related to memory. Only problem here is that we have to put somewhere the right to DB. In this example, I would probably do this in the serial number constructor, but that's, again, this is part of the things that you need to consider when you address ownership. Who takes ownership, who returns it, and what happens in between. OK, so now we're going to briefly go over a few of the standard library classes using RAII. So this is very, very common. This is a very common pattern, and I think it's very, by itself, you can tell that it's very useful. String and vector, of course, free memory on destructor. Stud.jthread, rejoin the thread on destructor. There's also some standard library utilities that you can use. For example, unique lock, which takes exclusive mutex wrapper. Shared lock, which is shared mutex wrapper. Lock guard, which takes ownership on a mutex in a scope. And what is probably preferred for usage is scoped lock, which takes ownership of multiple mutexes, but it also has an internal algorithm that avoids deadlock. So if I have two mutexes and they are dependent, I don't want to be in a case where one of them might prevent me from taking ownership on the other. I should use this one. And under experimental namespace, you can also find scope exit. I think it's very useful. So this one's actually a general purpose scope guard. There's additional library that I think you should check. I don't know if you heard about it. The guideline support library. This is a library that is written by the ISO C++ core guidelines. And it's implemented on MSVC currently. There's a link there. And in this library, you have, it's called JSL, you have owner. Owner is not like what we saw, shared PTR or unique PTR, because it's not dealing with memory. It's dealing with ownership, as I mentioned it, in other cases. For example, with the database. So you can use owner to wrap your object and prevent multiple ownership to it. Okay, so any questions so far? All right. So as promised, now we're going to talk about the future. A few proposals suggest changes in ownership model. And again, when I say ownership model, and I want to emphasize that this talk is trying to talk about ownership in a broader sense. I mean more than just smart pointers, but start with smart pointers. We have a proposal that actually proposes being able to have operator equal between smart pointers and regular pointers, etc. So this is an interesting proposal. It haven't been forwarded yet. There's additional proposal that talks about, it's called pointer lifetime and zap and performance too. And the point of this is to mark in memory pointers that were released so that we can do additional things with them. For example, garbage collector is a utility that cares about marking pointers that were released, because garbage collector have basically a few stages. First, you release the pointer, for example, but you don't necessarily clean it at the same moment. So you can, meanwhile, put some kind of flag in the value of the pointer, and then when the garbage collector reaches this pointer to free it, it can tell, according to the flag, its state. An additional proposal, as I mentioned, not related to smart pointers, is related to ownership, is a proposal talking about what is a view. So the ranges library, which I chair its study group, and I'm not, I can't, be, I'm a bit biased about it. Yeah, sorry. I lose words occasionally. So I think it's, first of all, I think ranges is a great library, just that you know, and I really recommend you to use it. It talks about views, and views are references to other ranges, but they don't hold ownership of the range. So this proposal is basically trying to emphasize what does it mean to have a view. And the last one that I think is very interesting is Type and Resource Safety in Modern C++ by Bjarne Stavstrup. But luckily, in this conference, Bjarne just gave a talk with the same name. So you can use your time machine or YouTube channel to go back and watch this talk. And I really recommend it because I think it means a lot about the future of C++ ownership. Okay. So takeaways from this talk. Consider data ownership in your design. Ownership is a window to advanced facilities. As I mentioned, garbage collector, statistics. Sometimes you wanna keep statistics on which objects have you created during your program and for what time did they lasted, etc. This is all things that you can do with ownership and with wrappers that represents ownership. And changes are coming. Thank you. Okay, so we have like 15 minutes. Any questions? Yeah.
So a question from online is, could you also talk about atomic shared pointer and weak pointer?
Yeah. Okay, so I don't want to go too deep into that because this talk is not focusing on multi-threaded programs, etc. The point was to actually focus on the facilities that we have. But yeah, so as mentioned, they can help you use the ownership in multi-threaded environment. There's not much to say about that, I guess. Yeah, go ahead.
When would you recommend passing a smart pointer to a function? Is it primarily for constructors, or are there other instances where passing a smart pointer instead of a raw pointer or reference is preferred?
So basically, I wouldn't recommend passing a smart pointer to a function, to be honest. Like, so I've shown how to do it and what to address when you do, but I think a clear API preferably doesn't share smart pointers with the library. So if I have a library that needs to do something, I'd prefer the user not to pass me shared pointer. I prefer probably to have some other way to communicate with the user as the functory methods that I showed. So it really depends on your case. When you do need to use it, just make sure that you decide whether you want to give the ownership, whether you want to copy the ownership, whether you want to keep the ownership to yourself. So, yeah. Sorry, I can't see. Oh, online question? Oh, repeat the question. Yeah. So, sorry, what's your name? Dustin asked, when do I recommend passing a shared pointer to a function? So I would really recommend not to do that, but use the second set of slides that I show if you have a library, one that use factory method. So yeah. Any other questions? Oh, yeah, sorry, go ahead.
So given that smart pointers seem to have some kind of overhead, when would you recommend using them over normal pointers?
Okay, so I hope I managed to pass that on, but unique pointer doesn't have a whole, okay. It depends, first of all, what you mean when you say overhead. Of course, if you care about compile time, if you care about runtime, that's different. Unique pointer almost have no overhead. So if that's the model that you want, and again, that means something. That means that it will complex your code because you saw that you can't pass it freely to a function. If that's a model you want, I wouldn't think about performance too much. If you're using shared pointer, I would pretty much recommend using shared pointer whenever you can, unless you're in algo trading or high frequency trading or something of this sort. I really think it have a lot of benefits. Most cases, you wouldn't want to treat the memory yourself. Again, unless you have special cases like memory pool or other things that you want to manage the memory yourself, and you just provide those sort of functory methods. And then in this case, of course, it's more advanced and you don't need them. Thank you. Ansel, go ahead.
Observation along those lines. I've found that by using shared pointer consistently in programs, you turn almost every memory management error into a fail to free error, which we have good tools to find.
It's true. Yeah. Yeah, so as Ansel said, always use them unless you don't. Yes, go ahead.
You had an example early on where you had a unique pointer and reset it.
Right.
Is there, at that point, can you comment on whether to use reset or whether to reassign it to make it unique?
Right. Okay, that's too far. I don't think I can. Yeah, never mind. I give up. Yeah, it's not that smart, this device. Okay, so for example, when you have a vector of unique pointers, it could be the case that when you have a more complex structure than just the pointer itself, it could be the case that you want to replace the object but keep the ownership because you don't want to damage or the integrity of the vector. Okay, so there's a few cases. I don't think it's a common use case, but I just basically did want to show that this exists. So yeah. Any other questions? Oh, go ahead, Alex. Yeah. Right. Yeah, it's true. Yeah, okay, so Alex just wanted to comment that if you should do algo trading, etc., there's allocators and PMR, which is a completely different topic, but very interesting one. And yeah, and I agree. You lift the sign, so I'm not sure what that means. Oh, okay, great, yes. Yeah, I learned, you see. A complete talk, and eventually I did. Okay, so thank you very much, everyone. If there's no further questions, thank you.